Principles of Operating Systems, Chapter 10, File Organization and Management. For most users, the file system is one of the most important parts of the operating system. The primary function of a computer is information processing. This information that's accumulated or created most often has to be stored. It's going to be organized in some kind of a file, and that file is going to be stored on some kind of storage medium, most likely a hard disk or tape. Files are collections of information that can be stored on disk or other non-volatile storage medium. Storage on non-volatile medium lets the information be accessed in later work session and helps to support the sharing of information between processes. The structure of files is designed to provide a convenient means of data access and information sharing. Then for a file system to do what it is it's supposed to do, designed to do, a file should have a reasonably long existence. It should contain the information in a form that makes it reasonably accessible, and it should be protected from access by unauthorized users and processes. In order that you access information in a file, you have to identify the file and then identify where in the file that information is. Files are given names to identify them, but with bigger and bigger storage capacities, the number of files in a computing system got bigger and bigger, and it started getting harder and harder to find unique names for all the files. Further, the lists of file names started getting so long it was hard to find a given file, even if you had a list of all the files available. Designers started to design file systems where files could be collected together in groups, and the groups are called directories. So we have a directory which contains a number of files. It might have a subdirectory which has files or other directories, and so on. A directory, like a file, has a name. Directories contain things. They can contain files and/or other directories. When a directory is contained in another directory, it's called a subdirectory. This kind of structure, directories containing directories containing directories containing files, lets us group files together if they have similar characteristics, like, for example, all the files that belong to a given user. This lets us find them more easily. It also simplifies the problem of creating unique names for all of the files in the system. You can identify the file using complete file name, also known as a full file name or an absolute file name. That's the combination of path information, identification of the directory, subdirectory sequence to get to the directory that contains the file, together with a relative file name, the final name of the file. Files in different directories then can have the same relative file name, which improves the simplifies our creation problem of unique file names. Files in a given directory all have to have different, distinct relative names. A file can be identified and located using the absolute file name, but users tend to stick to the simpler relative file names. The operating system will include a file management system to facilitate the use of files. What the management system has to do is provide a means to store data organized as files, to provide a bunch of functions that can be done, things you can do with those files, and support the association of a set of attributes with files. What a typical file operation would include the ability to create files, delete files, open files, close files, read from files, write into files. There are several terms that get used a lot when we're discussing file management, file operations. Of course, the term file. Frequently consider file as made up of a bunch of records. The records might be made up of several fields, and a group of files might be considered together as a database. Now, not all operating systems are going to provide file management systems that will deal with fields of records as subdivisions of a file. In particular, Unix and Unix-like systems don't deal with that. The operating system simply considers any file just to be a collection of bytes. Any file structure additional to that has to be provided by the processes making use of the file. A database, as we said above, is a collection of files that contains interrelated information. A car dealership might keep information about employees in one file, information about cars that are available to sell in another file, and information about money in a third file. A school might store information about the students in one file, information about the teachers in another file, information about courses, who teaches them, who's enrolled in them, in another file. users and processes make use of the information in the files in a database. Usually, there's going to be a separate database management system, DBMS, that supports the interface with the database. But the DBMS, Database Management System, depends on the operating system to provide support with essential operations. Things that a user or a process should be able to do. It should be able to retrieve all the records in a file, retrieve a specific record from a file, retrieve the record immediately following the last record retrieved, backstep, retrieve the record immediately before the last record retrieved, retrieve several records from the file, insert a new record into a file, delete a record from a file, modify the contents of a record in a file. A record is a collection of related fields that's treated as a single unit. In our previous example, the car dealership, the employee rec file might well be a collection of records, each record identifying a single employee, including a name and a social security number. Depending on the design, a record might be of fixed length or variable length. Employee name is likely to be of variable length, but a social security number is a fixed size. It also depends on, it's also possible that a file could have records with only one field. Recall in Unix files, all the records are same size, 1 byte. Of course, if there's only one field, then the distinction between a record and a field doesn't exist. They're the same thing. A field is a basic element of data with a single value. It'll have a name and a data type. It might have a fixed size or variable size depending on the data type. In the case of a variable size data, when it's stored, the actual representation might include a subfield to identify the size, the length of the value, how many characters in the string, for example. Or there are data types whose storage includes a terminating symbol. A file is a collection of information that can be stored on a secondary storage device. A file can be referenced or identified by name. Typically, they are structured as a sequence of records of the same type. The file can be created, can be deleted, can apply access control mechanisms to identify which users and which programs can access the file and which programs and users cannot. In sophisticated systems, The access control mechanisms can even be applied at the record or even the field level. The file management system is part of the operating system, and like any other part of the operating system, the reason that it's there is to help the users of the system. To use the file management system, each user should be able to create, delete, read, write, and modify files and have controlled access to other users' files if the other user grants the access. Should have control of what type of accesses are allowed to his or her own files. Should be able to move data from one file to another. Should be able to back up and recover files in case something happened to damage one of them. Should be able to access his or her files by name rather than coded numeric identifier. Of course, when you're designing the operating system, you have a different perspective on how that system should operate than does an end user. From the point of view of an operating system designer, a file management system should meet data management needs for the users, guarantee that the data in the file are all correct and valid, optimize system performance, provide input-output support for a variety of storage device types, minimize potential for lost or destroyed data, and provide a standardized set of input-output interface routines to user processes. And of course, for multi-user systems, they also have to provide necessary multiple input-output support. The complex interactions between users and processes and the storage devices is most easily understood as a sequence of stages. At the final lowest level stage, there's the device drivers. The software that communicates directly with the peripheral devices. This software is responsible for starting up the I/O operations on the physical devices and for detecting and responding to completions of I/O requests. The basic file system, or physical I/O level, is the part of the system that deals with where the information is stored in the secondary media. The basic file system deals with blocks, pages, segments, units of storage that are exchanged with the disk or tape systems. It's concerned with the placement of these blocks, pages, or segments depending on the system, in the system where these get stored, where they are located, and it's concerned with the buffering of the blocks in main memory. The I/O supervisor is responsible for file I/O initiation and termination. It maintains control structures that deal with device input-output, scheduling, and status of the files. It selects the devices that the input-output is going to and from, concerned with scheduling disk and tape accesses and to optimize performance. It assigns buffers for the input-output and allocates secondary memory. The logical I/O stage of the file management process is an interface between the access method stage and the I/O supervisor stage. Access method stage identifies the part of the file that's affected, the part that's being updated or the part that's being copied. The I/O supervisor identifies the appropriate data buffer so that the logical I/O program can copy data to or from appropriate locations in primary memory. The access method stage then deals with the logical subdivisions of the file. The I/O supervisor stage deals with the physical subdivisions related to the data storage. And logical I/O stage translates, converts from one format to the other. There are several different ways that a programmer can structure or organize the data file. Choosing one, the programmer has to consider several factors: access time, ease of update, storage economy, maintenance, and reliability. Which factor should have priority depends on what the file is for, what application is going to use it. Each method, each organization structure has advantages and disadvantages.